Welcome back. Today we're going to be talking about solving systems of equations using substitution, part 2. Let's go ahead and take a reminder about how we use substitution. So here's a reminder about the steps we use for solving using substitution. We're going to choose one equation and isolate either x or y. Then we're going to substitute in the equation a variable into the second equation, solve that equation, and use our answer to solve for the remaining unknown value. Now let's take a look at example A. So here we are at example A, and we've got 5x plus 5 equals y and x minus 3 equals y. So the good news is we have to isolate one of the variables, and both of these equations have the variable isolated for y already. So we can choose either equation to substitute in. It doesn't matter which one because we're going to be substituting for y either way. So I'm going to just substitute the x minus 3 into the one above. So we're going to get 5x plus 5 is going to be equal to x minus 3 because we're substituting in that x minus 3 for y. All right, now that we substituted in, it's time to solve our equation. We've got a variables on both sides situation, so we're going to go ahead and draw our wall. We're going to move things around. We got to get variables on one side, constants on the other. So we'll subtract an x on this side, subtract an x on this side. These are going to cancel, leave me with 4x plus 5 over here is equal to negative 3. Got a one-step equation at this point, so we're going to go ahead and subtract 5 from both sides. We've got our two-step equation, so we've got 4x equals negative 8. And then our last step is we're going to divide both sides by 4. And when we do that, x is going to be equal to negative 2. And that's great. That gives us one of the numbers in our ordered pair, but we're going to have to substitute that back in. It doesn't matter where we substitute it in, so I'm going to substitute it into the easiest one, which is the x down there minus 3. So I'm going to substitute in negative 2 for x. We've got negative 2 minus 3 is going to equal y. Negative 2 minus 3 is going to give me negative 5. So negative 5 is equal to y. So then my final answer is negative 5 is negative 2, negative 5 as my ordered pair. Now let's take a look at example B. So here we are at example B, and again we're going to write our answer as an ordered pair, solving for x and y. We've got 5x plus y equals negative 2, and negative 3x plus 6y equals negative 12. So bad news, none of our variables are isolated, but the good news is only one of our variables has no coefficient. So that's the one that I'm going to focus on, that y there. So I'm going to try and get that y by itself. So I'm going to bring the 5x plus y equals negative 2 down. I'm going to go ahead and isolate that y by subtracting 5x on both sides. When I do that, these are going to cancel, leaving me with y equals negative 5x minus 2. So now that I've got that y isolated, I can substitute it back into the other equation. So I'm going to do that substituting it for y. So I've got negative 3x plus 6, parentheses, negative 5x minus 2, close parentheses, equals to negative 12. Now I've got myself a multi-step equation that I know how to solve, so I'm going to go ahead and draw my wall. I'm going to distribute. So bring down my negative 3x. 6 times negative 5 is going to be negative 30x. Positive 6 times negative 2 is going to give me negative 12 equals to negative 12. Now I've got to get my variables together. So I'm going to group my like terms. So I've got negative 33x minus 12 is equal to negative 12. My last step is going to be, not my last step, but my next step is I'm going to add 12 to both sides. These are going to cancel. Negative 33x is going to be equal to 0. And then my last step is going to be to divide both sides by negative 33. And when I do that, negative 33 divided by 0 into 0 is going to be 0. So I now know that x is 0. So that's nice. That's an easy one to substitute back in because I can substitute that wherever I'd like. I'm going to substitute that in which one I think is easiest, which is that 5x one at the top. So I'm going to do 5 times 0 plus y is equal to negative 2. 5 times 0 is 0, and I just end up with y equals negative 2, so that was real easy. So negative 2 is my y-intercept, or my y point here, and that brings us to the end of this problem. Let's go on to the next one. So here we are at example C, and again solve for x and y, write our answer as an ordered pair. So this time, again, we don't have a variable that's isolated, but we can see this positive y here has no coefficient, so it's the easiest one to go for. So that's what we're going to do. So I'm going to add an x to both sides to make that happen. When that happens, these are going to cancel, leaving me with y equals positive x plus 3. So that's great. That's already isolated. So now I'm going to substitute that back into the other equation. So I've got negative 3x plus 3, substitute in x plus 3, because that's what now stands for y, and that's going to be equal to 4. So now it's going time to solve my equation, so I'm going to draw my wall. I'm going to I'm going to distribute, end up with negative 3x plus 9 is equal to 4. Then it's time to combine my like terms, and that's probably not going to end particularly well, because negative 3x and positive 3x is going to give me 0. So then I just end up with 9 equals 4, and as we know, 9 does not equal 4. So in this situation, what we have is no solution. Okay, so yes, just like equations, systems can have no solution, so this is no solution, or better represented as empty set. So there's no solutions here. This is as far as we can go. Now let's take a look at the last example. Here we are at example D, and again, same deal. We're solving for x and y, and we're writing our set as an ordered pair. So again, this time the good news is y is already isolated here, so we don't have to worry about doing anything with that, so we can just plug it right in. So we're going to do that now. So we've got negative 4x, substituting 4x for y, so I've got positive 4x plus 2. It's going to be substituted in there for y, and then equals 2. All right, so good news is there's nothing to distribute here, so we can just go ahead and solve our equation. So we're going to go ahead and combine our like terms. So we've got negative 4x and positive 4x. That's going to give me 0. And so then I'm just left with 2 equals 2. That's great, because we know that 2 always does equal 2. So in this particular case, our answer is all real numbers as our answer. So all real numbers. So all real numbers is our solution. All right, and we can represent that with the all real numbers symbol. That brings us to the end of this problem. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.